Hi everyone, this is Becky, and in this video we are going to do a review of dimensional analysis. So dimensional analysis, if you remember from physics, is also called the fractal label or train check method, but essentially what you're doing here is we're calculating or we're solving problems through using units as a conversion factor, right? So thinking about units and thinking about not worrying about the number, but just making the units work. So if I have, let's say that I know I have a quantity where I have, so 100 centimeters is equal to 1 meter, right? So 100 centimeters is equal to 1 meter. So if I take this and I divide both sides by 1 meter, what I end up with, so that cancels out, is 100 centimeters over 1 meter, and that term equals 1. So if I multiply anything by this term, this is equal to 1. So I'm not changing the quantity. What I'm changing are the units. So I'm representing the same quantity, but I'm expressing the answer or the thing in a different unit, right? Because this is essentially multiplying by 1. Okay. And so if I have, for example, let's say that I have 75 centimeters, right? And I know that for every 1 meter, there are 100 centimeters. I know that I have 0.75 meters, right? Because the centimeters are going to cancel out because they're the same, one on the top, one on the bottom. So algebraically, they cancel out. So 75 centimeters is the same quantity as 0.75 meters. It's just a different unit, right? And it's a way for us to think about, okay, how do I figure out how much the quantity that I have is in different units, okay? So to help us get a handle on this, okay, so this is a chart that you've seen before looking at the common metric prefixes. Since we work in metric, the ones over here that are starred are the ones that you really do need to know. So you need to be able to convert or know off the top of your head kilo, centi, milli, micro, and nano. Remember, this is the symbol, so km is a kilometer, micro m is a micrometer, nanogram is and g is a nanogram. And then these are the orders of magnitude that correspond to whatever that prefix is. So when we're setting up our conversion factors, let's say that I want to relate kilometers to meters, right? This is 10 to the third. Put this number next to the base unit, right? So 1 kilometer is 10 to the third meters, right? Or 1 nanogram is 10 to the minus 9th grams. That way, you don't ever have to worry about changing the sign on the exponent in your conversion factor, because if you put it next to the base unit, that sign will always be correct. It's also perfectly correct to say that there are 10 to the 9th nanograms in 1 gram. But again, then you have to convert the sign over, and it makes it a little bit hairy. If you put this next to the base unit, then you don't have to worry about that. It's always going to be correct to say that 1 nanogram is 10 to the minus 9th grams. Okay? All right, so you do have to know these, so commit them to memory. And then once we know them, and once we can think about the relationship between the units that we're talking about, we can do some basic unit conversions involving dimensional analysis. So remember, dimensional analysis, we're multiplying by a series of ones, so the quantity that's on the top has to equal the quantity that's on the bottom in our conversion factor. And essentially our goal here is just to make the units work, right? Just to get to the right unit. So if I have 0.25 kilometers, I'm going to put that over 1 just to make my life algebraically easier, right? I know that for every 1 kilometer, I need kilometers on the bottom because it's on the top over here. There are 10 to the third meters because kilo is 10 to the third. So the kilometers are going to cancel out because I have the same thing on the top and the bottom. I'm going to end up in meters, and it's going to be 250 meters, okay, when I multiply that through. All right, so I can do the same thing starting in a base unit and going in a different direction. So if I have 1.25 times 10 to the minus 5th meters over 1, right, I know that for every 1 nanometer, I'm going to nanometers, so I need that on the top, and meters on the bottom. There are 10 to the minus 9th meters, right? And so I can cancel out the meters. I'm going to end up in nanometers. So, and when we put that in the calculator, or even when we think about how these units work in scientific notation and when we're dividing by exponents, remember dividing by exponents is the same thing as subtracting. So in this case, this is going to be 1.25 times 10 to the fourth nanometers. Okay, I can do the same thing. In this case, I'm going from a unit that's not a base unit to a unit that's not another unit that's not a base unit. So I have 435 micrometers, and I'm converting that to kilometers. Rather than trying to do this in one conversion factor, I'm going to do it in two, because that way I don't have to calculate how many micrometers are in a kilometer and potentially make a mistake. So I'm going to go to meters first. So 1 meter is 10 to the minus 6th meters is 1 micrometer. Right, and then there are 1 kilometer is 10 to the third meters, my gosh. And then so when we do this, we're going to end up multiplying by everything that's on the top and then dividing by everything that's on the bottom. So I'm going to take 435, multiply it by 10 to the minus 6th, and then divide that by 10 to the third, which is going to end up equaling 435 times 10 to the minus 9th, which in proper scientific notation is 4.35 times 10 to the minus 7th kilometers. Okay. So pretty straightforward, right? Remember, you can use as many conversion factors as you want. The only important thing, the key thing for conversion factors is that the number that is on the top here, or the amount that's on the top here, has to equal the amount that's on the bottom. So whatever's on the top has to equal whatever, quantity-wise, whatever's on the bottom, it's going to be in a different unit. And the goal is just to make the units work, right? So to just work out what's canceling out and make sure that you're ending up in the right units on the top. All right. We can also do this with 2 units. And so in this case, I have a number that's in kilometers per hour. So remember that kilometers per hour is really 55 kilometers on the top and 1 hour on the bottom. So I can do the same thing here in terms of unit conversion. I'm just going to treat each unit separately. So I'm going to do whatever one I want to do first and then come back and do the other one. So in this case, let's do kilometers first. So there's 10 to the third meters in every 1 kilometer. So that cancels out the kilometers, and now unit-wise, I'm in meters per hour. So I have to convert the hours to seconds. I don't know how many seconds are in an hour, but I do know that there are 1 hour is 60 minutes. Now I need hours on the top here because it's on the bottom over here. And then I know that every 1 minute is 60 seconds. So that I can then put this in my calculator. So unit-wise, let's do units first. I've converted my kilometers to meters, so I have meters on the top, and I have seconds on the bottom. Everything else cancels out, which is the units that I want to be in. So I can put this in my calculator and get an answer. So that's going to be 55 times 10 to the third divided by 60, divided by 60, multiply everything on the top, divide by everything on the bottom, and that gets you an answer. And that answer is, I don't know, I have to put it in my calculator. That divided by 60 divided by 60. I screwed up. Anyway, get you an answer. Okay. We can do the same thing here again, right? So 0.32 micrograms again per liter. So that's really micrograms on the top and liters on the bottom. And so I can convert that using dimensional analysis to nanograms per milliliter, just picking out whatever term we want. So okay, so I'm going to do the one on the top and then the one on the bottom. You can do the one on the bottom first. It doesn't matter what order you go. So I have micrograms, so I know that there are 10 to the minus 6th grams in every 1 microgram. And then I know for nanogram-wise, for 1 nanogram, there are 10 to the minus 9th grams. So the grams cancel, the micrograms cancel. I'm left in nanograms on the top, which is what I want. So right now I'm in nanograms per liter. I got to convert that liters to milliliters. So I know that there are 10 to the minus 3rd liters in every 1 milliliter. And then so I can plug that in and get an answer. Again, I'm going to multiply everything on the top, divide it by everything on the bottom, which actually ends up canceling out. You'll notice here, right? So this is 10 to the minus 9th divided by 10 to the minus 9th, which is 1. So this is actually 0.32 nanograms per milliliter. The number didn't change, but we have changed the units. Okay. More tricky thing here is dealing with what happens when we have squared or cubed units. remember that a meter cubed is really just a meter times a meter times a meter. So if I'm doing this conversion factor, or if I'm doing this in dimensional analysis where I have 0.6 meters cubed, and I know that there are, for every 1 millimeter, there are 10 to the minus third meters. So if I only do this once, I'm actually only canceling out one of these meters, and so I'm going to end up with meter squared times millimeters. So what I have to do is I have to do it 3 times, or I have to cube my conversion factor, and I'm cubing the whole thing. I have to do it, so it's the same thing as doing this, having this conversion factor written out 3 times to convert all of those units, all of those meters to micrometers, or to millimeters, right? Okay, so it's the same thing here. This one is rare. We're not going to see this one very much, but we are definitely going to see conversions involving 2 units and conversions involving 1 unit throughout the rest of the year. So if this is something now you have questions on, try these practice problems here. So these are here. Hit play when you're ready to hear the answer. So pause the video, hit play when you're ready to see what the answer is. Okay, so if I'm converting nanoliters to nanoliters to milliliters, sorry, right? So 4.33 nanoliters. I know that for every 10 to the minus 9th liters is 1 nanoliter. And then I know that for every 10 to the minus 3rd liters is 1 milliliter, right? So we can put that in our calculator and get an answer that's going to end up being 4.33 times 10 to the minus 6th milliliters. Right, looking at the way that the exponents work, okay? Using 2 units. For the next one, when I have 5.25 times 10 to the negative 3rd grams per 1 milliliter, right? So I'm going to do the milliliters first, just to change it up a little bit. I know that for every 1 milliliter, there are 10 to the minus 3rd liters, and then I know that for every 10 to the minus 6th liters, there is 1 microliter. So the microliters they stay. Liters cancel, milliliters cancel. So now I'm in grams per microliter. And then I'm going to convert the grams to nanograms. So I know that for every 1 nanogram, there are 10 to the minus 9th grams. And then, so unit-wise, the nanogram, or the grams cancel. Oh my God. The nanograms and microliters stay. And so we end up with an answer, whatever that answer happens to be, in nanograms per microliter. And it looks like you're going to be dividing by 10 to the minus 6th, which should be 5.25 times 10 to the 3rd is what I'm getting when I do that. Double check, make sure I'm correct with that. Okay. So then the next one, we have 2.67 nanometers cubed, which is a volume unit, and we're converting that to milliliters. So we know that 1 centimeter cubed is equal to a milliliter. So I have to basically get this nanometers cubed to centimeters cubed. So 2.67 nanometers cubed over 1, and I know that, let's see, for every 1 10 to the minus 9th meters is 1 nanometer. I'm going to cube that conversion factor, and then I know that for every 1 centimeter is 10 to the minus 2 meters, right? And I'm going to cube that conversion factor, and then I know that 1 milliliter is the same thing as 1 centimeter cubed, and then I can do that and do the math here. Remember, the important part here is that you're cubing these conversion factors, so you're not dividing by 10 to the minus 2nd, you're dividing by 10 to the minus 6th, and multiplying by 10 to the minus 27th over here. So you're going to get a number that's pretty darn small. So it's 2.67 times 10 to the 21st, times 10 to the minus 21st, right? So 2.67 times 10 to the minus 21st milliliters is 2.67 nanometers cubed. Which makes sense. A nanometer cubed is a really ridiculously tiny unit, so it makes sense that it's going to be a really tiny number in a unit that we think about. Okay, so given all of this, this is something that Marie and I are gonna really expect that you are very, very comfortable with. We're posting practice on Canvas with answer keys if you're feeling uncomfortable with using dimensional analysis. Again, it's really going to make your life 100% easier if you do it and if you're comfortable using it. If you have any questions or you want to just work on some practice problems, please come by during C&C, and we'll see you later.